Well, hello everyone. Sorry for having a change to our usual schedule. I'm going to be making a video of the lesson that you would have done. And so let's get started. So we're going to look at, we're essentially just finishing off 8.2 and then we can get started on 8.3, the final section that you need for this week's homework and for the test. Well, 8.2 is the area of surface of a revolution. And we're going to look at how do you use your TI-84 or whatever TI calculator you may have to evaluate complex intervals, because there are going to be some situations where the integral that you end up trying to evaluate is basically either too complex to do or it might even be impossible to do. So what you can do as a kind of backup plan is to calculate the answer numerically using your calculator. So it will essentially be an estimate, but a very accurate estimate. So in question 17, we're being asked to take this curve from y equals 0 to pi upon 2 and rotate it about the y-axis. So first thing we have to do is decide what is the appropriate formula for this situation. Well, since you're rotating about the y-axis, it has to be one of these two. And secondly, since it's using y's, it ends up being this one. So the surface area is going to be the integral from c to d, 2 pi g of y, the square root of 1 plus g dashed of y squared dy. And in this story, that's your c, that's your d, and that guy is your g of y. So our surface area then is going to be the integral from 0 to pi upon 2, 2 pi g one plus the derivative of this guy squared. Okay. Cos squared y is really a chain rule. It's cosine y all being squared. So you multiply by the power, you get 10. Reduce the power by 1, you get cosine y. And then you differentiate cosine y to get negative sine y squared. So what we now have is combine them and you get 10 pi cos squared y. If you square this, you essentially get 10 squared, which is 100, negative sine squared, which is positive sine squared, and a cos squared. And you would try, typically at this point, to find some way to eventually evaluate it as an exact answer. And the usual strategies of use trig identities. Is it a perfect square? Can we do a u sub? Could we even do an integration by parts, I guess? But none of them work. So what we have to do is we have to estimate it with a calculator. And you'll know the question that's asking you to do that because they tell you to give the answer to like 4 or 5 decimal places. So first thing you do is you make sure you're in radians, which we are. Then I'll do y equals, and I'll type this expression in. So 10 pi. Now to get cos squared y, we don't actually have y's, we have an x button. So I'm going to call it cos squared x's. So you do a bracket, cosine x, and square it. Then you have a square root of 1 plus 100. Sine squared and a cos squared. Same kind of idea. Do a bracket, sine of x, and then square it. And then another bracket, cosine of x, and square it. And that should be it. We'll go to the window and make it from 0 to pi upon 2. 0 pi divided by 2. And then just to sure, to be sure everything's fine, I'll do a zoom 0. basically that should eventually sketch the curve. It looks something like that. Essentially, this curve is what that expression looks like if you put it in, if you try to draw it. Okay, since I have a curve, I can now go second calc, option number 7. It's asking me for a lower limit, which in this case is 0. I press enter. It's now asking me for the upper limit, which is pi divided by 2. Then you wait a few minutes or seconds, whatever, and it should get you an answer, 84.0135 to 4 decimal places. And there we go, 84.0135 to 4 decimal places. And that is it. So the next thing we're going to be looking at is 8.3.